All right, guys, welcome to day 4. Today in algebra, we're going to be talking about solving inequalities in one variable and being able to represent the solutions in interval notation and on a number line. I can write an inequality from a number line. I can solve multi-step inequalities and justify each step, and then I can translate a word problem into an inequality and solve. Okay, so these are the main goals for us today. To start with, it says here, what is the difference between an equation and an inequality? Okay, well, first off, an equation normally has one solution. Okay, and I said normally on this one because there are special cases where we can have no solution or many solutions. I'll say, we know it as all real numbers. All real numbers. Okay, so also when we see an equation, we see an equal sign with that. When we're dealing with inequalities, okay, inequalities, we're looking at lots of solutions. Or a range of solutions. Inequalities, you will know them as the following symbols. We've got these four right here, and we need to know what each of these four symbols mean. For the first one, this one is a less than symbol. I'm going to erase this for a second and use a capital L. Okay, I know that this is a less than symbol because back in the day, I would always get them confused which one was which until I realized that if I straightened this guy up a little bit, he looks like a capital L for less than. Whereas the other direction that would not make an L, if I straightened it up, it would be backwards. This one is my greater than. Okay. If we're graphing on a number line, when we're graphing inequalities, what we're looking for is we're looking for a range of solutions. So let's say that we were going to be graphing, let's say we're going to be graphing x is less than 5. What we're looking for is we're looking for the solutions for this that would show numbers that are going to be less than 5. So what would we do? So what we would do is we'd create a number line, and on that number line we'd put a 5 there. And we're going to put an open circle on 5 because it just says x is less than 5. Since we're not including 5, we would use an open circle around it. And what we want is we want values that are smaller than 5. So numbers that would be smaller than 5 would be like 4 and 3. And what would happen is we would see that anything that's smaller than 5 would be any value that would be to the left of 5. Anything that's to the right of 5 would be greater than it, and we wouldn't want to shade that because we only want to shade the part that's true. If we wanted to graph a greater than, so if we were looking to graph, say, x is greater than 3, what we would do is we would take our number line, put 3 on there. And just like before, I'm going to have to put a circle on 3, but for this, and for this one, since I'm not including 3, we would use an open circle on that. And then what we would do is we're looking for values for x that would make it, that would be bigger than 3. So the numbers that are bigger than 3 would be like 4, 5, 6. And we would notice that those are values that are to the right of 3. So we would shade to the right. And then for the next one, I erased these guys. This one here is, it looks just like the less than, but there's that extra line underneath. What that means is we have a less than or equal to. Okay, when we have a graph that's a less than or equal to, let's say we were going to try to graph x is less than or equal to 4. What we would do is we would take our number line, make sure 4 is on there. But this time, instead of using an open circle, we put that circle on there, we want to fill it in because it says less than or equal to. And to show that that equal to portion is there, you would fill that in. And then we want to have values that are smaller than 4. So numbers that would be smaller than 4 would be 3 and 2 and 1 and 0. Basically anything that would be to the left of 4. So we would darken that part of our graph and then make sure you put an arrow on the end so that you know that it's going to continue in that direction. And then if we had, the last one says greater than or equal to for this one, this is a greater than or equal to. Okay, so let's say we were going to graph x is greater than or equal to 1. What we would do is we would draw our number line and we put 1 on there. For the greater than or equal to, I know that when I go to put the circle on 1, this would have to get filled in because it is an equal to. And then we would have to ask ourselves, our solutions need to be bigger than 1. So numbers that would be bigger than 1 would be like 2 and 3 and 4. And you would notice that those are numbers that are to the right of 1. So we would shade to the right of 1. And then we have our graphs. What's nice about graphing inequalities is if you have the variable that's on the, or if you have the variable on the left side of your inequality sign ends up shading in the direction that it points. So for instance, that first one said x is less than 5. Since x was on the left side of the inequality, notice that this pointed in the direction we shaded to the left. For x is greater than 3, x was on the left side of the inequality sign, then the sign ends up pointing in the direction and we shaded to the right. And you can see that that third one there, x is less than or equal to 4, we shaded to the left, and then for x is greater than or equal to 1, this is pointing to the right, and we ended up shading to the right. And this only works is it when x is on the left hand side of your inequality sign and then your value or your numbers on the right hand side. If it's not in that order, you would have to flip-flop it in order for it to point in the direction that you'd want to shade. All right, so what we're going to be doing today is, now that we kind of have the idea as to how to graph inequalities, we're going to take that a step further and we're going to solve problems that contain inequalities, so a singular one. Okay, so let's take a look at example 1. Example 1 here says solve if 3x minus 7 is less than 8. Okay, so what we'd want to do on this is try to isolate x. So we would have to use inverse operations to do that. You kind of want to treat your inequality sign as if it was an equal to sign, and you might want to draw like that little equator value or line down the middle to separate. All right, but our goal overall for this problem is to isolate x. So right now, 3 and x are being multiplied together. So the first thing I would need to do is to get rid of that minus 7. So using inverse operations, I would add 7 to both sides. And then I get 3x, just bring down your inequality of less than, and then that would be 15. And then from here, To get the x by itself, we want to get rid of the 3, so divide by 3 using inverse operations, and we would get x is less than 5. All right, so inequality notation, x is less than 5. Interval notation, I'm going to come back to. And if we were to graph this, since it's based around the number 5, I want to start by putting a circle on 5. This would be an open circle because this just says is less than. 5 is not being included, so we want to do an open circle. And we are looking for the values that are less than 5. X is on the left side, so our inequality would point in the direction we want to shade. So it's saying to shade to the left. So we would go to the left of our value of 5. Like I said, interval notation, I'm going to come back to after we get these examples done. All right, example 2. Example 2 says negative 4x plus 3 is less than or equal to 19. Okay, so just like the example above, our goal is to isolate x. So we're going to do inverse operations in order to get there. So we're going to start by subtracting 3 from both sides. And when we do that, we get negative 4x is less than or equal to 16. All right, so from here, in order to get x by itself, we are going to divide both sides by negative 4. So those would cancel. And then we're going to get x is something, and then we're going to get negative 4. All right, on this one, we have to be extremely careful. When you notice that the number that you are going to be multiplying or dividing by in order to isolate x, when that number that's doing the multiplying or dividing is negative, your inequality symbol is going to flip direction. So it's no longer going to say x is less than or equal to. When it flips directions, it would say x is greater than or equal to, and that would be negative 4. So let's make a note here that says when you multiply or divide by a negative value, okay, so when you multiply or divide by a negative value, the inequality symbol is going to change direction. So this would be the inequality notation answer. So I would put over here, x is greater than or equal to negative 4. If we're going to graph this, let's see, we are running off of our graph a little bit. So I'm going to just make it work. Okay, so it's pretty impressive. All right, so what we want to do on this one is we're going to put a closed circle on negative 4 because it says is greater than or equal to. So closed circle on negative 4. And we want our solutions to be greater than that. So we want to make sure that numbers that are going to be greater than negative 4 would be numbers that are to the right of it. So we want to shade to the right. Notice that since x is on the left side of your inequality, that inequality is going to point in the direction where we're shading. It's pointing to the right, so we shade to the right. Okay, interval notation, we're going to come right back to. All right, so how do I solve inequalities? Well, our goal, our overall goal when we're solving them should be to isolate x. All right, so how do I do that? The first thing that we want to do is we want to use inverse operations to isolate x. Okay, one other thing, or one thing that we have to be concerned about though is this part right here that says, copy. I'm going to paste it. Oh. Okay, this says technology. There we go. When you multiply or divide by a negative number, the inequality sign is going to change direction. So be careful with that. Make note of that. All right, so now this last thing that we also have to worry about in this part here. It says my notes on interval notation. Okay, interval notation. You have probably no idea what it is, and they're asking for it in those two above examples. So let's figure out what it is first, and then I'm going to have you guys go back and try to work those out. Okay, so interval notation. Things to think about in interval notation. You're going to have two values. You're going to have a smaller value, and then the second piece is going to be the larger. Okay, it might be an actual number such as 5, 7, 12, doesn't matter, it could be negative, but it might just trail off to positive infinity or negative infinity. So you might see numbers in there, you also might see infinity symbols, it kind of depends. But on the left-hand side, there's, like I said, there's two parts to it. On the left side, it's going to be the smaller value. On the right side, is going to be the larger one. And then it's going to be made up of, or these two numbers are going to be inside either parentheses or brackets, or a combination of a parenthesis and a bracket. What you want to keep in mind is when you can use which. You will use parentheses to indicate that it's not included. And you are going to use a bracket if the value is included. If it is not included, you would see it represented as an open circle on your number line. Or it would be like a less than or greater than. If a value is included, it would show up as a closed circle on the number line. And if you were, or if we are dealing with something that is trailing off to infinity, infinity always, whether it's positive or negative, is always not included. So infinity symbol is always going to be around parentheses, or parentheses is going to be around that. Okay, so with that being said, I want to go back to these problems. All right, if we are going to take these problems or these solutions and we want to write them in interval notation, like I said, it's going to be made up of two values. You're going to have a smaller value, comma, the larger value. So you want to read your graph from the left to the right. Where does it start on the left? Where does it stop on the right? So for this example here, see on our graph how it just keeps arrowing at the end here. So the furthest spot left would be negative infinity. So in this first position for interval notation, I would put negative infinity. And then what I would do is I would just keep tracing the graph and see what's happening. And I can see that the furthest spot my graph goes to the right is 5. So my highest value I would say is 5. So I would go furthest on the left, comma, furthest on the right. And then what you want to do is to go back and see if those should get parentheses or brackets. We said before, infinity is always going to get parentheses, so I put parentheses around that negative infinity. With the 5, when I look at the 5 has an open circle there indicating that it's not included. So if it's not included, it would get a parenthesis. It is possible to have something that would look like this, negative infinity, comma, 5, with the infinity in parenthesis and the 5 in the bracket. That is possible to have a combination of parenthesis and bracket. If that's the case, that 5 would have been like a circle that was filled in. Okay. All right, so let's take a look at this next one in interval notation. This one says x is greater than or equal to -4. When I look at this, I know I'm going to have the very furthest left comma to the very furthest right on my graph. My graph starts at -4. So that's the furthest left this graph goes. So I'd say -4, comma, and the furthest right it goes, you can see when it is graphing, it goes to the right and has that arrow at the end, indicating that it's just going to keep going to the right. So I'd put an infinity around that. I put it, sorry, an infinity in that spot. Then go back and see if you should be using parentheses or brackets. So the -4 is a circle that's filled in, so you'd want to use a bracket around it. And then infinity always, always, always is going to get parentheses. So your interval notation for this one would look like this. And here's an example of when we're doing a bracket and a parenthesis. So it is okay to have that. So we did this. All right. Example 3 says to solve each inequality, write your final solution in interval notation. So example 3, A says -1/4 times the quantity p minus 12 is greater than -2. All right, so on this one, I would treat this as if there was an equal sign there. And our goal is to isolate p, which is inside that parentheses. So the first thing we want to do is to get rid of this number in front, which is -1/4. It is okay to distribute it, but then you're going to be dealing with fractions. So I would suggest the easiest way to get rid of this is to multiply by its reciprocal on both sides. So the reciprocal of -1/4 is -4/1. All right, so if you were to multiply both sides by -4/1, those would cancel, and you would be left with p minus 12 is greater than 8, because -2 times -4/1 is 8. All right, one thing I did a mistake, and I did it on purpose to see if anybody would catch that. This inequality symbol here, this should flip direction. And the reason why it should flip direction is because we multiply both sides of that inequality symbol by a negative number. So when you multiply or divide by a negative, your inequality sign is going to change direction. So this should actually change direction. All right, so from here, I almost have p isolated. What we want to do next is to use inverse operations to get rid of that -12. So we're going to add 12 to both sides. And we would get p is less than 20. If we were to graph p is less than 20, that would be 20 on our number line. We would represent that with an open circle. And we would want values that are less than 20. So that would mean that we would be shading to the left side for less than. If we wrote this in interval notation, we would say the furthest left is -infinity. And then it stops once we get to the furthest on the right, which is +20. Okay, infinity is always going to be parentheses, so put a parenthesis around that. And then 20, since it was an open circle, we don't want to include it, so we would put parentheses around that. And then this would be our answer in interval notation. With B, B says 5 minus the quantity 4w plus 3 is less than or equal to -4 times the quantity 2w minus 3. All right, so there is this minus sign in front of this parenthesis, the first set of parentheses. So I'm going to sneak a little 1 in there. So I'm going to start this problem by distributing to eliminate any parentheses. So when I do that, I'm going to get 5 minus, when I distribute that -1, that's going to become minus 4w. And then -1 times 3 is minus 3. And then that would be is less than or equal to, and then distribute the -4. You would get -8w and then plus 12. And it's a plus 12 because -4 times -3 is positive 12. If you don't know your negatives in terms of multiplying, adding, subtracting, dividing, please be on the safe side and just use your calculator. It's completely fine. Okay, so we eliminated our parentheses. So the next thing we want to do is to combine any like terms on the left side of our of that inequality. Do the same thing on the right side. So on the left side, we have some like terms. We've got 5 and -3, or 5 and -3. So we could combine those to give us 2. So that would be 2 minus 4w. And then on the right side of the inequality symbol, that does not have any like terms, so we just say -8w plus 12. All right, from here, I'm going to keep using, or I'm going to use inverse operations to isolate w. So I'm going to, before I start messing with the constants, I'm going to bring all the w's to one side of the inequality. So start by adding 8w to both sides. And then you will get 2 plus 4w is less than or equal to 12. Keep going by subtracting 2. We would get 4w is less than or equal to 10. And then from there, I would divide both sides by 4 and get w is less than or equal to 2.5. If we were to graph this, put 2.5 on there. For this one, it would get filled in because it's less than or equal to. And because it's a less than or equal to, we want numbers that are less than 2.5. So that would mean anything to the left, less than, think left of 2.5. This would be our graph, and then our answer in interval notation. We want to go furthest left to the furthest right. The furthest left is -infinity, comma, the furthest right is 2.5. Infinity always gets parentheses. The 2.5 is being included, so I am going to put a bracket around it. And that would be our answer in interval notation. Okay, with C. C says 14x plus 5 is less than 7 times the quantity 2x minus 3. All right, so for this one, I want to start by distributing to get rid of those parentheses. So when we do that, we're going to get 14x plus 5 is less than 14x and then minus 21. All right, so now that I distributed, look for any like terms on the left side of the inequality, look for like terms on the right side of the inequality. We don't have any of those. So next thing I'm going to do, since we've got x's on different sides of the inequality, I'm going to bring them all to one side. So my next step would be to bring, using inverse operations, I'm going to cancel out the 14x's on the left and bring them to the right. The problem is when I cancel them out from the left, if you notice, they also end up canceling out from the right side. And you will be left with 5 is less than -21. Okay, so we're getting one of these special cases, and I know it's a special case because when we went to solve it, all of our x values went away. So it's either going to be no solution or it's going to be all real numbers if it's a special case. When I look at this, you have to, or when you look at this, you need to ask yourself, is 5 less than -21? Is a positive number going to be smaller than a negative number? And your answer, of course, is no. A small number or a positive number is not smaller than a negative numbers. So this is going to be a no solution. If you were graphing this, you can put a graph, I don't know, put 0 on there, but don't have anything filled on your graph. This would be no solution. And then for D, I did D on here, and D ends up being like C. So I think I'm going to change something. Okay, on D, I would like for you guys to change the inequality symbol so that it says greater than or equal to. So I want you to highlight this one. So just flip its direction. All right, so when we go to solve this one, first thing we want to do is we want to distribute to eliminate any parentheses. So I'm going to take the 5 and I'm going to distribute it. So it's going to be 5m plus 25 minus 2m. Remember, I'm having you guys change the direction of this inequality so that we don't get the same type of answer as the problem before it. All right, so this is going to be greater than or equal to 3m plus 17. All right, so distributed. Next thing you want to do is to combine like terms. On the left side of our inequality, we do have some like terms here. So I'm going to add those together, subtract those in this case. 5m minus 2m is 3m. So this is going to be 3m plus 25 is greater than or equal to 3m plus 17. All right, so now when I look at this, I got my m's on different sides of the inequality symbol, so I want to bring them all to one side. So I'm going to do inverse operations to do that. I'm going to get rid of the 3m on the right side by subtracting it off. So on the right side, those are going to cancel, but they also cancel on the left side. What's going to happen then is 25 is greater than or equal to 17. All right, so now because your m's canceled in this problem, I knew that this was going to be a special case. So it was either going to be no solutions or all real solutions. So in order to determine what case it is, read your answer. This says 25 is greater than or equal to 17. So is 25 greater than 17? Is it bigger than 17, or is it equal to 17? Yes, it is bigger than 17. So since this is true, this would be all real solutions. If you were going to show the graph of that, all real solutions, you would just include everything. You would darken everything on that number line. If you're going to write this in terms of interval notation, you can say from negative infinity to positive infinity and put those in parentheses. So that's why I had you guys change that symbol on D so that it didn't give us a no solution like example C did. All right, we're getting there. Let's take a look at example 4 here. Example 4 says the solution to each inequality is listed below. Represent the solution on a number line and in an inequality notation. Okay, so 4a says 4 comma infinity with a 4 in bracket. So what we're going to do is we're going to graph this. So what we want to do is we want to put a circle on 4 because that's the value that we are working with. So I'm going to put a circle on 4. I know that because there's a bracket, that would mean that it's included. And to show that the value is included is you do a filled in circle. So we're going to fill in 4. And then this says 4 is a smaller value and then infinity is our larger one. So that would mean that we need to be going to the right side of 4, such as 5, 6, 7. So we would shade to the right and draw an arrow at the end of that graph. If we were to write this in inequality notation, we're going to start with x, always start with your variable, and then use the value that we are centered around. In this case, we're working around the number 4. When you go to write your inequality, think about the direction that it's pointing. This one's pointing to the right, so we're indicating that we want solutions that are greater than 4. So since we're pointing to the right, the inequality symbol will point to the right. And then we want to determine if we should underline the greater than symbol or not. Because 4 is being included, we'd want to underline that and make sure that it reads as a greater than or equal to. If you didn't have that underlined, then that 4 would be an open circle. All right, B, inequality notation. We got negative infinity to negative 1. Okay, so for this one, we want to put negative infinity, and then we're going to go to negative 1. So negative 1 is the number we're going to center around. On negative 1, I'm going to use a parentheses or an open circle because there's a parentheses. And then what we're concerned about is that negative 1 is going to be the biggest value on our graph. We need to highlight to negative infinity. If we are going to write this in inequality notation, we want to start with our variable of x, and we want to end, or we want to talk about negative 1. The solutions that we want are the ones that are smaller than negative 1 or less than negative 1. So to indicate a less than, we would point it to the left. So it would say x, do your inequality symbol to point to the left for less than. X is less than negative 1. We're not going to underline this because negative 1 was not included. That circle did not get filled in. All right, example 5 says to translate each phrase into an inequality. All right, A says Trey is saving up to buy a new iPhone that cost at least $800,000. He already has $420 in savings. All right, so on here, we got to think about what he's doing. He's saving to buy a new iPhone. So he's looking to purchase a phone. And in order to get to that phone, he needs to save money. And he could take his savings, what he's going to save, and what he already has. Okay, so if we take into account what he plans on saving plus what he already has saved, that amount needs to be greater than the price of the phone, or it could be equal to the price of the phone. If it's equal to the price of the phone, or if it's greater than the price of the phone, he will be able to purchase the phone. So we don't know how much he needs to save, so I'm going to say that that part is X, plus the amount that he already has in savings. He already has $420 in savings. That needs to be greater than or equal to the price of the phone, which is $800. So for this one, it would be X plus 420 is greater than or equal to 800. All right, the next one. All right, the next one says 5 less than X is greater than 18. All right, so is greater than, okay. When I read this, I try to mark up the sentence that I'm reading. So the first thing that I read is 5 less than X. Less than means subtraction. And less than and more thans are a little confusing because really what you have to do is you have to flip-flop their order. So what that means is I have to start with X and I have to subtract 5 from it. So we're going to take those two pieces for our less thans and more thans, and you have to flip-flop their order. So that would say X minus 5 is greater than. So like I was saying before, I can never remember which direction was which for my greater thans or less thans. So I'd start to think about the letter L. So I would know that this way is a less than. So I want a greater than, so I would have to point it to the right. This has to be greater than 18. So just by reading down below and marking what I had above it, I have my inequality. This would say X minus 5. And then I'm going to do that greater than symbol, and then 18. All right, for C, C says the product of 2 and X is less than or equal to the sum of 9 and X. All right, so for this one, I'm reading is less than or equal to. Okay, so the product of 2x and 5. Product means multiplication. So I know I should be multiplying 2x and 5. So what would that look like? 2x parentheses 5. That shows that I'm multiplying those two. And then I want that to be less than or equal to. So less than, think of a capital L. Have it squeeze in a little bit. You got your less than symbol. So we got our less than or equal to the sum of 9 and X. Sum means addition. We want to add 9 and X. So one goes in the front and the second piece goes behind. And then we have our inequality. We'll just clean it up. This says 2x times 5 is less than or equal to 9 plus x. All right, there you have everything from day 4. If you go to do your homework and you're finding that you're not getting answers correct or you're still struggling to understand any concepts, please make sure that you reach out to your teacher or you go to the Math Resource Center, go to those office hours and get your questions answered. Thank you and have a good day. Bye, guys.